Okay, now we're going to talk about a number, the square root of 2. Okay, you had mentioned other kinds of numbers that you knew about were fractions, right?
Yeah.
Like 3/2 or 29/15 or things like that.
Yeah, but what about irrational numbers?
Okay, so this number, the square root of 2. Where's a place where the square root of 2 comes up? You might know.
In triangles.
Okay, what's a triangle that has the square root of 2 in it?
Well, it would have this. The hypotenuse would have to be the square root of 2.
Okay, what's a triangle whose hypotenuse is the square root of 2?
1, 1, the square root of 2.
1, 1 square root of 2, and this comes from the Pythagorean theorem.
Yeah.
Do you remember the Pythagorean theorem?
It's a squared plus b squared equals c squared.
Right, so 1 squared plus 1 squared equals 2.
Squared.
And what squared equals 2? Well, the square root of 2.
Yeah.
And so in ancient Greece, I think, they tried to understand numbers like this.
Yeah.
And they thought, I don't know like math history perfectly, but I think they thought all numbers could be ratios of integers, like fractions. But the square root of 2 can't be a fraction. Do you remember? We've talked about the proof of this. Do you remember how that goes? If you assume the square root of 2...
It's like rational.
Square root of 2 equals a over b in lowest terms, right?
Yeah, and then we found something that was lower terms than that.
How did we find the contradiction? How does this proof go?
Well, we square both sides.
Okay, so we square both sides. We say 2 equals a squared over b squared. Okay.
And
What do we do now?
then
And a and b are both integers, remember?
Yeah.
And they're in lowest terms. Remember what we can do here?
we can, then maybe we can add a square root.
We can move the 2 to the other side.
Well, this is already pretty nice on this side. What's complicated about this equation?
The fraction.
Okay, how do we make it?
Multiplied by b squared.
Okay, so we get 2b squared equals a squared. What can we say now?
We can say
Something really simple.
Well, we can say that b squared is a squared over 2.
That's true, we could say that, but there's something super simple we can say about this, like one of the most basic things about integers.
well,
a squared is 2b squared. What?
Yeah?
That's what it says.
Think about even and odd. Which one of these numbers has to be even?
A squared has.
Why? Why does a squared have to be even?
Because this side is even.
This side's even because it's a multiple of 2.
Yeah.
But
Right?
if it's even, we could have pulled a 2 out of it.
Okay, so if this is even, then this equals, call it 2m squared.
Yeah.
So 2b squared equals 2m squared. 2b squared equals 4m squared, squaring both things.
Yeah.
Now I divide by 2. b squared equals 2m squared. What can we say now?
But we could have. But no, this has to be even.
Now b has to be even, so we figured out a was even and b was even. What's the problem?
But we said they're in lowest
We
terms.
said they're in lowest
Ah.
terms. Ah!
Now it's irrational.
Okay, so now it's irrational. Now when I say the square root of 2, you're not bothered by that, right?
Yeah.
But like the ancient Greeks had no idea what that even meant, right? Are you bothered by the square root of 2?
No.
No. So we get used to these things over time. We learn about them. Right? You ready to learn about something new?
Yep.
Yeah.
All right, here we go.